Hello students. Under the topic linear differential equations with variable coefficients, we are going to solve problem 3. This problem has appeared in one of the question paper. So kindly write this problem as an assignment problem. So include this in the assignment. So consider the equation x squared y double dash negative 7x y dash plus 15y equal to 0. Show that phi 1 of x equal to x cube for x greater than 0 is a solution of the equation, and find the second independent solution. So first of all, we have to show that phi 1 of x equal to x cube is a solution of this given equation. In order to show that, we need to show that phi 1 satisfies this equation. That is, to show that phi 1 is a solution of this equation, what we have to show is x squared phi 1 double dash minus 7x phi 1 dash plus 15 phi 1 is equal to 0. So this is what we have to show. In order to show this, first we have to find phi 1 dash, phi 1 dash and phi 1 double dash, and then substitute here. Now what is phi 1? Phi 1 is given to be, so phi 1 of x is equal to x cube. So from this we get phi 1 dash to be equal to 3x squared. So on differentiating x cube, we get 3x squared. Again, on further differentiating this, phi 1 double dash of x will be equal to 6x. So now we have obtained phi 1 dash and phi 1 double dash. So let us substitute in this equation and let us check out whether phi 1 is a solution of this equation or not. So first we will consider the left hand side of this equation, that is this. So which is x squared phi 1 double dash, so multiplied with 6x, minus 7x multiplied with phi 1 dash, which is 3x square. So 3x square plus 15 multiplied with phi 1. What is phi 1? It's x cube. So write x cube here. So that is equal to, so this becomes 6x cube minus, so this turns out to be 3 7 times is 21. So 21x cube plus 15 x cube. So now 6 plus 15 is 21. So this is equal to 21x cube minus 21x cube, which is equal to 0. So therefore this implies that the given phi 1 of x equal to x cube is a solution of the given equation. So we have proved that phi 1 of x is a solution of this equation. Now we have to find the second independent solution, which is phi 2 of x. So to find phi 2 of x, let us consider, so let us take phi 2 of x to be equal to u phi 1 of x. So phi 2 of x, that is phi 2, will be equal to u multiplied with, what is phi 1? It is x cube. So u multiplied with x cube. Now we have to prove that phi 2 is a solution. We have taken phi 2 to be the solution of the given equation. So this equation, that is, let us mark this equation as 1. So now phi 2 is a solution of this equation. This given equation, let us mark this as 1 and this as 2. So this given equation, now it means that phi 2 will satisfy this equation. So wherever we have y, let us replace it by phi 2, because we have considered phi 2 equal to u x cube as a solution of this equation. So that equation turns out to be, so equation 1 becomes x squared phi 2 double dash minus 7x phi 2 dash plus 15 phi 2 is equal to 0. Now we shall find phi 2 dash, phi 2 double dash, and then substitute in this equation in order to find phi 2. So for now phi 2 we have to be equal to ux cube. So using this, let us find phi 2 dash. Now from this, phi 2 dash will be equal to, we have to use UV method. So first u multiplied with 3x squared plus Now we can have x cube as it is and differentiate u, which will become u dash. So therefore phi 2 dash will be equal to 3ux squared plus u dash x cube. Now using this, now we shall find phi 2 double dash. So from this, phi 2 double dash will be equal to, now again we have to apply UV method here. So we can have u as it is and differentiate 3x square, which on differentiation becomes 6x. Okay, and then plus, now we will have x square as it is, and if we differentiate u, it becomes u dash. So 3x squared u dash plus, now similarly this one, these two. So first x cube we will have as it is, so u double dash plus u dash we will have as it is, and we get 3x squared, and that will be equal to, on simplifying this, we get 6ux plus 3u dash x squared plus x cube u double dash plus 3u dash x squared. Now gathering the terms, we could see that these two terms are similar. So writing in the order of the power of x, we get phi 2 double dash to be equal to, first we will write this, so x cube u double dash plus, adding these two we get 6u dash x squared plus 6ux. So now we have found phi 1 dash, phi 2 dash, and then phi 2 double dash. Now let us take phi this and substitute over here. Let us mark this as equation 2, and we can substitute these two in equation 2. So now we have substituted phi 2 double dash and then phi 2 dash, okay, phi 2 dash and phi 2 in this in equation 2. Now after substituting, let us simplify this. So this is implies, so when we multiply this x squared with this, we get x to the power 5 u double dash plus 6x to the power 4 u dash plus, and then 6ux squared negative, now 3 7 times is 21, so negative 21 u x cube, and then negative 7 u dash x power 4 plus 15 u x cube is equal to 0. Now let us gather the terms. So now if you see, so this is the term with x power 5. So x to the power 5 u double dash. And then we can see that x power 4, that is this term 6x power 4 u dash, and here also we have minus 7 u dash x power 4. So when we gather those two terms, we get negative x power 4 u dash. And if you see, this 6ux squared plus 15ux squared is 21ux squared, which gets cancelled with negative 21ux squared, and so this is equal to 0. Now let us divide this equation by x to the power 5. So if we divide this equation to the with x power 5, we get u double dash minus u dash by x is equal to 0. So from this we get u double dash is equals to u dash by x. So we can rewrite this as u dash by u double dash by u dash is equals to 1 by x. Now integrating on both the sides, so integration of u double dash by u dash dx is equal to integral 1 by x dx. We know that if the differentiation of the denominator is the numerator, then we can say that this is equal to the log of the denominator. So log of u dash is equal to the integration of 1 by x is log x. So from this we get u dash to be equal to x. Now again integrating this u dash with respect to x, so dx. So what do we get? When we integrate u dash, we get u. So that is equal to, and when we integrate x, we get it as x squared by 2. So the value of u is equal to x squared by 2. We can this 1 by 2 is negligence, so we can take u to be equal to x squared. So we can just have it in this way. So we can consider u to be equal to x squared, and actually we are finding the solution phi 2, which is equal to u phi 1, that is u multiplied with x cube. So now what is u? U is x squared. So x squared multiplied with x cube is x to the power 5. So therefore we have obtained the solution phi 2 to be equal to x power 5. So already we know that phi 1 is equal to x cube is a solution. And now we have obtained phi 2 equal to x to the power 5 to be another solution. The only part remaining is we have to prove that these two solutions are linearly independent, for which we have to prove that the Wronskian of phi 1 comma phi 2 is not equal to 0. So the Wronskian of phi 1 comma phi 2 is equal to the determinant value of phi 1 phi 2 phi 1 dash phi 2 dash. Now that is equal to the determinant value of phi 1 is x cube, phi 2 is x to the power 5, phi 1 dash is 3x squared, and phi 2 dash is 5x to the power 4. So the determinant of this will be equal to, so the determinant value is 5x to the power 7 minus 3x to the power 7. So that's equal to 2x to the power 7. And this value is not equal to 0 since we know that x is greater than 0. So therefore this is not equal to 0 because in the question it is given that x is greater than 0. So therefore the Wronskian of phi 1 comma phi 2 is not equal to 0, which implies phi 1 and phi 2 are linearly independent. With this, we are done with the solution of this problem. Hope you have understood this problem. Thank you.